Now let's have a look at how we can apply Pythagoras' theorem to problems involving circles. So make sure you look over your class notes for the properties of circles that we've had a look at, and that's what we're going to be applying here. Let's have a look at example 11. A circle has a diameter xy of a length 13 centimeters. Z is a point on the circle such that xz is 5 centimeters. Find the length yz. Okay, so always a good idea to begin with a diagram, so let's do that. My beautiful circle, here's my center, and we have a length diameter of xy, so that's x. My diameter is, sorry, that's not x. XY kind of looks like a Pokeball. So that's 13 centimeters going across. Z is a point on the circle such that xz is 5 centimeters. Find the length of yz. Okay, so that means let's put z here somewhere. So it's told us that x to z is 5 centimeters. And we want this length yz. Now, from what we saw with properties of circles, right, this here is a right angle. So that means if we want to find the length of yz, which is, let's call x, this is just Pythagoras' theorem, right? So x squared, it's not the hypotenuse, it's one of the shortest sides, so it's going to be 13 squared take 5 squared. So x is going to be square root of 169 take 25. So x is going to be root 144. Remember that we're going to disregard our negative answer, so x has to be 12 since x has to be positive. So therefore yz equals 12 centimeters. And we're done. Move on. Example 12. A circle with radius 8 centimeters has a chord of length 10 centimeters. So we're going to have to use what we learned about chords. Find the shortest distance from the center of the circle to the chord. Okay, let's draw another circle. Label the center point. Draw a chord. So radius is 8. So let's draw that. So radius is 8 centimeters. And it has a chord of length 10. Alright, so let's put the chord, I don't know, here somewhere. So this chord is 10 centimeters long. Find the shortest distance from the center of the circle to the chord. Okay, so we use a different color. There's my chord. Alright, so remember that the shortest distance from the center of the circle to the chord is always the line that makes a right angle with the chord. So from here, well, since we know, let's draw a triangle. Now this is going to be an isosceles triangle, as we found out. And these two sides, so these two sides are equal, and they're going to be both 8 centimeters long because it's also the radius. Okay, now the shortest distance here is going to be x. That means that, okay, if the whole chord is 10 centimeters, also remember that this dotted line bisects the chord, which means it cuts it in half. So that means each side of this chord is 5 centimeters, right? So I'm going to get rid of this 10 centimeters now. I can get rid of this 8 centimeters as well. So there we go. And if we want to find x, again, let's use Pythagoras' theorem. So x squared, or if I just go straight to, we should be able to do that by now, square root of, again, it's one of the shortest sides, so we have to start with the hypotenuse. So 8 squared take 5 squared, which is square root 64 minus 25 is square root of 39 centimeters. Alright, so the shortest distance from the center of this circle to this chord is going to be root 39 centimeters long. Example 13. So now we're going to start dealing with tangents, which is going to make things a little bit trickier because you have another concept to implement. So let's have a look at how to do that. A tangent of length 10 centimeters is drawn to a circle with radius 7 centimeters. How far is the center of the circle from the end point of the tangent? Okay, so that's a better circle. So let's put our center here. So a tangent, okay, let me draw the radius here. So that's 7 centimeters radius. Now a tangent is a point that touches the outer edge of the circle here, and it makes a right angle with the radius. So if it's not the best diagram, but say I do that, makes a right angle with the radius, right? And the length of the tangent is 10 centimeters. So just start drawing the tangent from that endpoint is what they want here. So unless they say otherwise, just use that as a general guideline. So the distance from, well, we want how far from the center to the end, right? So that's this distance right here. So I don't have to do it too many times. I'm going to draw this here. And this is going to be, call it x. Alright, and then, oh look, it's Pythagoras theorem again. So see a common theme here. I'm going to go straight to x. This time it is the hypotenuse. So 7 squared plus 10 squared, which is root 149 centimeters. And you can convert that to a decimal and round it if you'd like. Example 14, a little bit harder again because we have more information. So let's see what we got. Two circles have a common tangent. Okay, so as shown in the diagram, they share the same tangent with points of contact A and B which are 7 centimeters apart. So if I blow this up, let me just draw on here, probably easier. The radii of the circles are 4 and 2, so let's say that's 4, and this other one, let's say that's where they touch point A and point B. That's 2 centimeters there. Find the distance between the centers. Okay. Maybe I put 4 centimeters here so I can draw a line. So if I draw a green line between the centers, this is what we want. You always want to try to draw a diagram when you come to these sorts of questions. Just helps you visualize it and helps you come up with a strategy a bit quicker, I feel. So there, that's the distance we want. So let's see what we can do here. Now, what do we know? What else do we know? That these are right angles, okay? And we want this green line of this shape here. Okay, well, if those two angles are right angles, think about what shapes we can create, right? So if you are thinking of a rectangle and a triangle, then you are correct. There we go. Alright, because that means if those first two right angles were identified, then that means we can create a rectangle like this, which means this side is 7 centimeters. And then since, whoops. Now see how this side is 2 centimeters? That means this bit where we created the rectangle also has to be 2 centimeters. So that means here is 2 centimeters. That might just be common sense, but there you go. And this must be a right angle too, because the point A to the center is a meet at 90 degrees. So, well, the fact that we already have a right angle on this side, and this is a straight line, means there must be a right angle here, right? So find the distance, maybe let's call it d this time. Again, you'll see that a lot of this is just Pythagoras. Distance equals the square root of, now this is the hypotenuse, 7 squared plus 2 squared. 49 plus 4 is root 53, positive root 53 centimeters, and if you want to, you can convert that to a decimal, but I'm just going to leave it there. Alright, so that'll give you an idea of how to incorporate your knowledge of circles and tangents to Pythagoras' theorem to solve problems.